All right. So this is like part one of two Git workshops we're going to run. The second one we'll do right after group projects kick off, and we'll learn about collaboration workflows. And we'll focus more there on branches and using GitHub to create pull requests and reviewing code and merge conflicts. Today is more about the mechanics of using Git. Some of this will be review, some of this is new. The goal is to dig a bit deeper into some core concepts of Git, like what they call the three trees, so to speak, what a ref is, and this term head that we can use to refer to a commit. There are some specific skills. We're going to look at unstaging code, uncommitting code, and a safe workflow for if you've committed and pushed code and need to undo it. If we have time, we'll look a little bit at undoing a commit with git revert, which is actually fairly straightforward. I'll talk a little bit about basic workflow stuff for using backup branches. And there's sort of three scenarios here that this workshop covers. I've added or staged code that I didn't want, and I haven't committed it yet. I did commit code that I don't want, but I haven't pushed it yet to my GitHub in the cloud, the repo in the cloud, or I've committed and pushed code that I don't want, right? And all of these are pretty common scenarios that you will run into either on your personal project or in life. Um, so some of these, the commands are relatively straightforward, but we're going to really dig into like what exactly Git is doing and learn some deeper concepts all the way along the way. And also, I'll talk about some workflow tips that can help make these safer operations for when you are dealing with like not one small file, but maybe a large number of files where you have to do some of these operations. Do folks have any questions before we dive in? All right. So, um, I have here, I've made a Git repo. It's up on our curriculum repo as well. There's really nothing that's happened yet. If I type git log to see a history of committed work, in fact, we don't have any commits yet. If I type git status, I see the branch name, I see no commits, I see some untracked files and this prompt git add to include what will be committed. Um, In a little bit, we'll look inside this .git directory, and this is what makes a Git repo, right? If I deleted this, this would no longer be a Git repo, but my code would still remain. And in a Git repository, my code is in one of three states, and these are what are called the three trees. And let me go ahead and give myself a little room here. And we'll make these guys a little bit smaller. And my code is either in what's called the working directory, staging, or index, and then what's referred to informally as the commit tree or head. And let me give ourselves a little more room here. Right, and we'll build out a diagram here as we commit and do work, and we'll see where work is. The working directory is literally my file system. And anything that's uncommitted or unstaged is in the working directory. So stuff over here is not staged, not committed, um, not protected, right? And that's where this README file is right now. If I type git status, I see here untracked files that are in the working directory. Once I run git add, and you can do dot to add all the changes, or if I want to add one specific file, I can do git add readme. And over here, I have the VS Code's built-in source control open, which by the way, if you like go to extensions, or if you open the VS Code sidebar, it's down here. There are other tools as well. We're going to see a graph tool in a minute. This one's just a simple one to help get us going. We see now that it's put stage changes over here. And in fact, if I wanted to, it just opens the changes and I could look at that and look at the details. If I type this git diff command, it doesn't show me anything, but if I do git diff dash dash staged, I see the difference between what's in, oops, excuse me, the staging tree and the working directory. And so here we do get some protection, right? So now our code is not committed, but it is staged, and we get some protection of the code by Git, right? There's not a commit, it's not as strong, but if I do like Git checkout the food to go to some other branch, I see here I still have my stage change. If I do Git checkout dash to switch back to the branch I was just on, then oh, it looks like for some reason it doesn't like that. Oh, and the issue I'm running into is because we haven't committed anything on this main branch, which is a pretty rare situation actually. It doesn't exist yet in Git's eyes, which we'll talk about in a little bit. So I had to use this -B to create a new one. We'll learn like what it means to create a branch in a little bit, but a branch without any commits really isn't a branch at all, is what we're seeing here. And we see this command use git rm dash dash cached to unstage. And in fact, if I want to, I could do, there's a couple ways to do this. There's the git rm cache command, and that one is maybe a little less safe. The reason is that you can actually delete files with git rm. There's also git restore. And this one is maybe a bit safer because we'll talk about git rm a bit later when we have some committed code. But if I do git restore staged, and then I want to give it the name of my file, I want to be specific here about what I want to restore. Let's see, it looks like this may not be happy without a commit yet is maybe the issue here. And if we try git rm cached, So that will also work. We'll see I'll show Git restore staged a bit later, I think. Um, that moves this back from staging into the working directory without losing any of my work. Right, and we can add it back now. And I'm curious if Git restore does this as well. Yeah, so Git restore is for later on. There's the three commands I do get a little can frankly be a little confusing. And I actually find it helpful that Git does give us this reminder here. So right now this work is staged. As we can see, we've got some protection around it. If I was to like in switching branches, the work is still there, but it's really committing where the work is we get the most protection from Git. And I'm going to go ahead and just type git commit. And actually, let's just as a nice recap, let's just put an empty file in here. Just as a friendly reminder, where I have stuff in my working directory and stuff in staging, but committing only takes what is staged and commits it. And I think of it as like if I'm baking like cupcakes or cookies or something, whatever is on the baking tray that you put in the oven, that's what gets cooked or committed, and this stuff does not. And we're going to add this git commit message. We're going to save it. And now we've got the README has been moved from staging into our commit tree or head, right? Where this is tracking work that is done. And in fact, we now have a commit on this branch. And over here in this graph, we can see this one commit. In fact, it shows us the changes that happen in this one commit. And now, right, if I type git log, I see something a bit more interesting. I see the commit hash and I see the README. And let's add a little more work here just to see a bit more and sort of refresh ourselves on Git. Let's add this empty file foo.py, right? And it's moving it from working to staging. And let's go ahead and commit this. And I'll just use -m to add a commit message. And now that's also here. And let's go ahead and let's make a change to the README. And let me close that out because that's actually not the file itself. And in fact, I had a minor change, and let's just add some exclamation points here as well. And so now I have some minor changes to my README. I'm going to add them, right? And I'm going to commit these as well. And in fact, I kind of like this automatic message here saying what file's been changed. So I'm going to uncomment those lines so it stays in the commit. And now we've baked some more cookies or cupcakes, right? And now this is in the commit tree or head. And now we can kind of see what a branch really is and why it's called a branch. And I know we've seen some of this before, but we can see that each commit really points back to a previous commit. And in fact, the most recent commit on a branch we call head. Um, and this is just one way of referring to a commit. And let me go ahead and pull this out a bit, and let's actually use, there is a Git graph VS Code extension, which I really like. There is this little graph here, but this one's much nicer. And if you go to extensions and you search for Git graph, it's going to be the first one that pops up with 11 million installs. And I do recommend installing this to play around. And I like this one because it lets us see a bit more of what's involved with the commit. We see there's a date, we see there's an author. Most critically, there's the commit hash, the number that uniquely identifies the commit. Interestingly, we see that there's information about a parent commit. And this parent's commit hash is 4D85, blah, 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 like B3F. And if I go here to this previous commit, lo and behold, that commit hash number 4085, blah, 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 88B3F is the same. So this is really sort of like a linked list where each commit holds a pointer to its parent. And these are just links in a chain. And head is what we call a ref or a reference, right? That points to the most recent commit on a branch. And that's really all that a branch is. And let's in fact add some commit hashes here, just so we can look at this. And when I check out a branch, all I'm doing is changing the value of this head ref to that most recent commit on that branch. And using Git graph, we can, let me close this out. We can see the commit. If I click here, I see all of the changes, right? And as we know, a change could be just a minor change to one file or changes across many files or creations of new files. And if I poke around now inside this .git directory, we're going to see some interesting things. So inside this .git directory, I see this file named head. And if I print out that file, I see it says refs heads main. And that is the name of the branch I'm currently on. In a little bit, we'll make another branch and we'll see this will actually change. But let's look in this refs directory that it mentions. And we see a couple interesting things here. We see a directory for heads and a directory for tags. And if I go into the heads directory, I see there's a file named main. And if I print that out, I see there's a commit hash. And in fact, if we pull up our source control, and let's look at our commit graph and let's see, does it show us? Yeah, that one doesn't show us the commit hashes. So let's use the big one. Let's look at the most recent commit here. And indeed, the most recent commit hash matches what it has here stored in this heads directory. And if in fact, let me navigate out of the .git directory. Or actually we can go. We'll stay there. Let me just open up foo.py. Let's add a hello message. Let's open up the README again. Let's add something to that. Right. And so now if we were to put this on the graph, we would have changes to foo.py and changes to README MD. And let's just call these minor changes. And we'll make this blue. These changes are in our working directory. I'm going to open up another terminal so I don't have to keep navigating around too much. I'm going to add.
Adam, did you stop sharing?
I don't think so. Can other people still see my screen?
Yes.
Yeah, you're still good.
Okay, awesome. Andy, are you not able to see my screen at the moment, or?
I resized the window and it just went away.
Yep, that's just Zoom life.
Check the tabs up on top. Make sure you're just not just in a meeting for your Adam screen.
Oh, got it. Okay.
Thank you. Actually, this is a good. Well, let me finish this one up, and then that's a good pause point for questions. So if I'm adding files one at a time, and I know, we've seen a lot of this before, I kind of want to warm us up here. If I'm looking at Git status, we see my changes to the README have been added, but these ones aren't staged. Note, by the way, now Git is saying, okay, you can use Git restore staged to unstage. Now that I have a commit, this is where Git is a little weird, right? It has its weird rough edges.
So maybe when you first start, just go ahead and just do a empty commit just to get the whole thing rolling.
Yeah, most of the time, with when you create a repo on GitHub, like it'll create a README or something like that. So it's just such a rare situation where you have a completely empty repo. Um, and actually, let me demo restore staged now that will work. So Git restore staged is a safe operation. I'm not going to delete or lose anything. But we've gotten in the habit, my guess is, of doing git add dot all the time, right? Because it's easy and it's fast when I'm working on code. I'm not always doing git add, readme.md or whatever specific file I'm working with. When you are doing these more like git operations that are moving things from one area to another, I think it is a good idea to avoid the dot and the wildcard and just be specific with your file names, even if it adds extra steps, because it just de-risks things. Because if I do something silly and like maybe instead of restore stage, I did git rm or the wrong command, it just reduces the risk and it's only one file that this is happening to. Nick, yes, sir.
Without a git ignore, how does it know not to include .git? Is that just like a default behavior?
That is a great question. I never thought of that, and it must be a default behavior. Yes. It's got to be something like that.
Because everything else pretty much has to go in git ignore, otherwise it will track it, right?
Uh
If you do like an add,
yeah.
dot all.
Yeah,
Okay.
correct. Correct. That's a really good point. It must be a default behavior that it just is ignoring the .git directory. Yeah, great question. I never thought about that one. So if we run restore staged, we'll see like we did with RM cached before, my work isn't it shouldn't be lost, and it's not lost. I'm just looking at the wrong. I was looking at the staged changes. So restore stage moves that work back from staging to the working directory. And I realize that we're occupying a lot of screen real estate here. And again, git add will move one thing over, and let's go ahead and let's git add foo as well. Um, it's not a huge deal when working on your personal projects, but as things get bigger, it is nice to have commits be a bit more self-contained. If I was doing this, I might commit the README change on a separate commit than the foo.py change. But we're not going to worry about that right now. We're just going to say minor README and foo updates. And now these changes have gone into the commit tree to head, right? This is our third tree that sort of captures the current state of our branch. And again, I'm going to just make up a commit hash here. And now this ref head is our most recent commit hash. And if I hop back over here and we look and we're deep in our Git directory here at refs heads, and we look at the head for main, we see it's this new value A826 blah 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 blah. And if I go to my Git graph and I look at my most recent commit, we see that commit is A826 blah 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 blah. So this is kind of cool, right? Because we can see how Git works. And this idea of like, what is head? What is a ref? Well, it's just a variable that points to a commit hash. But this is how Git actually keeps track of stuff. And it actually has something called tags. And if I type git tag, we don't see anything. If I type git tag dash dash help, we see a whole bunch of commands, and we're going to create a tag in just a minute. And I believe dash A will create a tag, and then we can give a message. So let's see if we can get this to work. Git tag dash A dash M. Hello, I am a tag. And let me get my syntax right here. My apologies. One moment. Yeah, so actually, I apologize. I haven't looked at tags in a minute. We can list tags, and if I'm going to create a tag, it should really look like this, where it's going to have a name. Often you use a version number for your tag. And now I can see that tag. But if I go into the tags directory, we see that this has now been created in the tags directory. And we see that that's also a commit hash, right? So whatever commit is currently checked out when I create a tag, that's what that tag stores. And so a tag is another example of a ref, right? So head is a ref, tag is a ref. If I was to check out a new branch, and let's just name it foo. And let's go back here and let's look in the heads directory. We see now there's another file in there named foo. And if I print that out, we see it's that same commit hash, right? And so this commit tree and head, all this is it keeps track of the most recent commit on a currently checked out branch. And it does that by keeping track of these refs named head. And so on this foo branch, let's say let me hop over and do this in the code. I've created a new file that's going to only be on this foo branch. And now if I look at my Git graph, we can see it shows us this tag. If you guys see right here where it says version 0.5, right? It shows us that ref. It shows us what head for main is. And then over here, it shows us this head for foo. And if we look at the commit hash for this most recent commit, it's 43C blah, 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 blah. Right. And if I'm going to go up here with my diagram, right, and 43C. Now that I've checked out this other branch, what Git has done is it's changed head. And if I look inside my .git directory, we're going to see a couple interesting things. Um, for one thing, if we look at the value for heads foo, we see 43C, blah, 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 blah. But also now, if I move up a level in this Git directory and we look at the file for head ref, we see it's pointing to ref heads foo, right? And now if I go back over here and I do git checkout main, and I look at the value of that head file, we see it points to main. And so we see that under the hood, Git is actually using a pretty simple setup with just files and commit hashes and files basically storing variables to keep track of how everything works. And that really all a branch is this ref that holds the most recent commit on that branch. And because every commit points back to its parent, if you have the most recent link in the chain, you can work backwards. So I just want to pause and check in and see what questions folks have or what's on people's minds. And how are we feeling? Do we feel like this starts to demystify Git a little bit and what it's doing under the hood? Okay, awesome. So that's one of the big goals for today. In that curriculum lesson repo, there's a link at the bottom to this really amazing site called Git from the Bottom Up. And I do strongly recommend reading through this. I think they do a great job of describing the guts of Git a bit more, talking about a repository, right? It talks about a collection of commits, this idea of the working tree, the index, what a commit is, and they describe it well here. A commit is a snapshot of your working tree at some point in time, because a commit could have changes across multiple files, right? So whatever's in my directory, whatever's in my working tree when I add it to staging, this is the snapshot of it that a commit captures, right? Um, and we've talked about refs and branches, and it goes a bit deeper, and it has this very nice diagram too of the three trees, right? And we've kind of seen this flow of I am writing code, I add code, it gets put in the index or staging, and then I commit code and it's committed to the repository. And I just want to pause and see if folks have questions or stuff that you're curious about before we check out some of the other scenarios. Okay, awesome. So we've looked at Git restore staged. Let's look at Git reset soft. And let's go ahead. We're not going to spend too much more time in the .git directory. I think this has been mentioned, but you should never, ever, ever modify anything in the .git directory directly. If you're doing that or you're contemplating deleting the .git directory, something has gone wrong. So you don't want to do that. So let's say that I'm working on some Python code. I'm on my main branch. I have all these files, and I also make a virtual environment. And I add all my work, and I'm going to make a commit. And my working directory is clean, and I'm doing great, right? And if we look at the graph here, and by the way, now we can see why like people talk about trees and stuff with Git now that we are starting to have some differences between the branches. Over here in purple, they have foo. And just for fun, in fact, let's check out foo real quick. And let's look at something on foo py, and let's add like just goodbye. And I really just wanted to do that just so we could have let's see, I'm a little surprised we're seeing foo up here. Yeah, the graph, I always get a little confused with the Git graph tool, to be honest. I would have expected to see like two. I would have expected to see this on this purple foo branch here, but it's not. It looks like main is now the purple branch. I think it's kind of showing us whichever one is more recent. So I don't want to get too lost in the sauce with the graph. Um, what I did want to show us with the main branch is I made a mistake here and I committed my virtual environment directory. And in fact, if I do git diff head -1, this is going to show me the difference between the current commit and the previous commit. And this tilde is like a minus symbol, right? And we can see these new files. If I look back 2 commits, we see these other changes. But I've committed this virtual environment directory, and that's not what I want. So now that I've committed this code, how can I uncommit it safely? So there's going to be 2 steps here. And the important thing here is I haven't pushed the code up to GitHub yet. So I don't have to worry about changing like another repo. First, just to be safe, I'm going to create a backup branch so that if I do something silly on my main branch, I can go to the backup branch and still have that work. And now we can use git reset. And let's take a quick look at this command. And it says reset current head to the specified state, right? So we can, in essence, move our commit history back. So I'm going to do git reset soft back 1 commit. And now something interesting has happened. It looks like I may have actually made a mistake. I may have committed more work than I thought on the main branch. I apologize because I thought that moving back would undo the .venv, but I must have made a mistake. And if we look, and that would explain my confusion with the Git graph earlier as well, where in fact now we can see the backup branch.
What do you think didn't happen that you expected to happen right now?
I thought that I had created, let's see, um, on this foo branch, I added a goodbye message. Okay, so that was specific to foo. Create Baz and hello. Maybe I did do that on main. I guess what I thought that when I would undo this commit, it would also uncommit the virtual environment directory file, which we do have here.
Did it not do that? I'm confused. I'm looking at changes to be committed. I only see Baz and hello is
Yeah, yeah, it didn't do that. Though I'm wondering, I might be getting confused here because maybe it's treating the dot file differently. Let's see. Let's see what happens if I do git reset soft head tilde 2. Let's go back 2 commits. Yeah, so something's funny with the virtual environment directory. Because I thought I had committed my virtual environment directory by mistake on purpose, along with some of these other files in a previous commit. let's see if the internet can help solve this for me. Get reset soft dot file. How get reset soft affects dot files. Yeah, so I would have expected get reset soft to do something with this dot directory, with this venv directory, but it doesn't seem to be. Right, this is exactly what I wanted to demo was get reset soft and having it move from being committed to staged. But for some reason that didn't happen. So I'll come back to that in just a second. But what we do see here is I've used that get reset soft to roll back a number of commits where I didn't lose any of that previous work, right? They've still been added. And in fact, if I was to go to my diagram and let's roll back up here a bit, basically what I've just done is I just took both of these commits and all this work and moved them here into the staging tree, right? If you look at, there's like a minor change to the README, to Baz, to foo, to hello. And if we do git diff staged, we can see here are those minor changes to my README. Here's the hello message, which I might have committed on the main branch by mistake. And yeah, so I'm not sure. I must have made a manual mistake somewhere in the process with the .venv file. But we do get to see here this get reset soft behavior. And then what I wanted to demo from here is, let's say what I wanted to do was very specifically change foo.py. Well, let's use git restore staged. And let's move foo.py out of staged and back into the working directory. Right, so I can use get reset soft to move something that's been committed to staged. And then I can use git restore staged to move something from staged back to the working directory. And by doing this, what I've done is if I do git status, I've safely uncommitted, in fact uncommitted 2 commits and then unstaged some work. But I still have protection because this code has been added. It won't let me just straight up and down delete it. And so now I can just safely make this one change I want. So let's say the change I want is in fact, I wanted to say this. And now we can add foo back. And now I have foo modified and now I can commit. And we're just going to say modified foo. Added Baz and hello. So in fact, I really ended up combining a couple commits here because if I look at my main branch, now I have what used to be work across a couple commits combined into one. And in fact, if we look at this foo branch, we can see that old commit history is still there. And then I have the backup branch here. Right, where we had this commit and this commit, and these two kind of got squashed together into one off of main. I do admit to being a little mystified why that didn't unstage the .venv file. If I do git rm.venv, it looks like what's might be happening here for some reason is the venv file might be being ignored. Okay, I think I know what's going on, guys. I apologize. I think in my global git config, I think I'm ignoring. I think somewhere I've told Git to ignore the .venv file because it was never even checked into version control. So I apologize for that confusion. Um, and in fact, we can double check this right now. Um, yeah, I'll have to poke around there to see if I did do something with my Git config or not. But I think that was the issue I was running into with the venv file was something external. And we'll just go ahead and add this. So I apologize for the confusion there, but we did get to see the workflow with Git reset soft in action. And most critically, how I can like combine these things, right? And what we in fact, what we have now is our main branch just has those 3 commits. Sorry. I clearly have to avoid adding, I think, the dots in these TL draw file names, because then if I click on them, it TL draw thinks I'm trying to open some sort of link. So what we saw was, and let me add some commands here. Let's add these in purple. We can use git reset soft to uncommit stuff and move it back to staging. And then we can use git restore staged and we can give it a file name to move something from staged back into the working directory. Right, so with git reset, I can uncommit previous commits. With git restore staged, I can unstage specific files. And then back here in the working directory, I can modify the file I have uncommitted and unstaged and then add and commit my changes. So this is like a nice workflow that I can follow, and this lets me do it very safely, and reduces the risk of me accidentally deleting code that I do care about. The last scenario I want to show is if we push code. And now if I go to this repo and give me a moment to navigate here. So we have our Avenger Git workshop, and I have all the code I've created. And let's say I open up one of these files. Let's say it's baz.py, and I print a message. And let's go ahead and add that. And let's go ahead and push it. So now, what if I realize I want to undo that commit? This does get a little trickier. Because while I could do git reset soft, and that moves my work from committed back to staged. That doesn't affect the code that I've pushed up. So here we have to be a little more careful. And we have a couple options. And let me go ahead and commit and push this code up. And we see this error now because I tried to do a git reset soft on my local branch. But if we look at the history here, there's a more recent commit I've made that I undid. And I have this unstaged change. And now I have these two branches out of sync. As the message says here, the tip of my current branch is behind its remote counterpart, right? If I go to git graph and let's just look at the main branch, because I did that soft reset, I have some staged and uncommitted changes. But even if I commit and try to push, I see this error message. Updates were rejected. And again, I've messed with my commit history here, right? And if we look at the commit history on my local machine, we have create readme foo, modified update, and then where I'm trying to fix this change. But if we look over at the commit history on GitHub, this most recent commit is different, right? Because I've only made this change on my local Git repo. And how do I get these two back in sync? Well, it's tricky. If I try to pull, I see this message, you have divergent branches because there's this final commit that's different. So there's a couple options here. And the thing to do is you have to know like what source of truth you want to use. If I know for sure that what I have on my local branch is the version I want, I can do a force push. And this is really dangerous because this is going to override the commit history here on the repo on GitHub with this commit history on my local repo. So you have to be absolutely certain. And now if I go over here and refresh this, we see the commit history has changed. Now, in this case, they still do the same thing, but if I had had this do something else, then it would have been a real problem. The other way to do it is if I change something right? If I've changed something and I have this same problem where the two don't match, if I know for sure that what I want is the version that's on GitHub, I can use git reset hard, and this will actually change a commit history. So this is dangerous. Now I can do origin main, and I'm telling git reset hard and use the commit history from origin from GitHub on the main branch and override my own commit history. You can also use git reset hard to go back to previous commits. In fact, let's go back to commits here. And if I type git status, we're behind the main branch by 2 commits. I've actually deleted commits with that git reset hard. If I didn't have that work on GitHub, I would lose that work forever. So again, git reset hard, you can delete stuff, right? You have to be really, really careful with git reset hard. I realize I've totally screwed up my local branch. Thankfully, I've been pushing. I have a previous version here that is okay, and I might lose a little work, but not a lot. So I am going to override my local branch with what's on GitHub. And now I get that work back. Right? So git reset hard, we have to be careful with. If I have oh, Carlos, yes, sir.
Real quick, the git reset hard origin main, does that kind of do the same thing as if you just do a git fetch or a git pull?
Good question. It does a git pull, but specifically, let's say we have the scenario was, let me do git reset soft head tilde1. And let me go ahead and do git restore staged Baz. And let's go ahead and change this to hello world. And let's commit it. And let's have it say Baz says hello. So the situation I have now is I have 2 different versions of this branch. Even worse, I have 2 different commit histories for this branch. Like, it doesn't matter that here the Baz file says this and here the Baz file says that. What matters is the commit history has changed, right? If I look at the head of the main branch, the most recent commit on GitHub, it's this commit here trying to fix Baz. If I look at the update README commit before it, it does this. Over here, well, update README is the same. Well, Actually, it looks like update readme might be different, so that actually might be an issue as well. But really, this most recent commit on my local branch doesn't exist on the remote, and they do different things. So Git doesn't know how to resolve this, right? It doesn't know which most recent commit is the truth now that we have these different Git histories. And if I do Git push, I see this error and it says updates. The push I tried to do was rejected because the tip or the head of my current branch is behind its remote counterpart. Integrate the remote changes with Git pull. Now, if I try to do Git pull to bring down those most recent changes, I get a different error. I have divergent branches. The commit history has changed for the same branch. And I need to specifically say how to reconcile them. We're going to learn about merging later on in the other Git workshop. That's where you manually like look at multiple files and tell Git which versions of different files to use. Um, that's not what the scenario I want to show here. The scenario I want to show here is somewhat simpler, where I need to decide on a source of truth. And so by doing git reset dash dash hard origin main, it does a git pull, but more importantly, what it does is it completely overrides my local repo and it overrides my local repo's commit history for this branch, right? Main on my local machine is going to get overridden with main here from GitHub. Does that
Okay,
help
yeah,
answer your question?
I think I was just misunderstanding what Paul was doing because I didn't realize Paul was trying to merge the changes rather than just overwrite.
Right. Right.
Okay, all right.
So, yeah. So pull, when the commit history is the same, or if there's like new commits, pull grabs whatever commits we don't have from GitHub for this branch and downloads them, right? And then applies them. And you can have a merge conflict show up from that, which we'll learn about later. But more specifically here, our problem is the commit history has changed. So we're doing the pull, but then we're also with the reset hard, we're overriding our local Git history. And now whatever, you know, I've lost forever anything I had locally on main that wasn't over here on GitHub.
Thank
So
you.
this is sort of like the nuclear option of working with Git and what you want to be careful with. Um, every now and then you need to use it. Same with the force push, right? This does the opposite. This would have overridden the main branch here on GitHub with whatever I had on the main branch on my local machine. And if I know that, what I have on my local machine is a source of truth, that's totally fine. But otherwise, you need to be a little careful. So the other scenario I want to show here is maybe I decide that I don't want this code at all. I effectively want to undo this work. I can use git revert. And let's see what this does. So let's actually quit this. Okay, so it did do the revert. Okay. So I actually reverted 2 commits back. Let's undo that so I can show this again. Um, And now if I do git checkout readme, it will undo. Or let's just do git restore readme, it will undo those changes. So let me try git revert one more time. I ran that command wrong. Let's do git revert head. I don't want to revert back one commit. I want to revert the most recent commit. And now we can see what this does. So let me go ahead and save this. Note that I did not have to modify any code here. And let's see if this graph updates. There we go. Let's look at this revert commit that get automatically generated and see what it did. It did something really simple. It did the exact opposite of the other commit. So, revert basically deletes whatever it is we tell it to revert, but it does it by making a new commit, right? So if I look at my commit history, I have this one commit here trying to fix Baz, where we've added this line. By running that command, git revert head, I told Git, hey, for this commit, I want you to make another commit that just deletes whatever is in there. And this is great because maybe I've changed like 3 different files and I realize, you know what, I just don't want any of this. I can use git revert to get rid of it, right? So in this case, this is a really simple example. But if we had changes across multiple files, git revert would delete all those changes, and it does it in another commit. And this is nice because this doesn't break the commit history, right? I haven't lost any work if I change my mind. Like maybe I want to revert my revert. Let's copy this commit hash. I could do git revert head, right? This would revert this most recent commit of the revert, but I can also use that commit hash. And I just need to hop to a different tab to get the git graph to update. And here we have reverted the revert. And if we look at the change, we see that it should be back. And there it is. It is indeed back. So revert is really nice because it uses commits, right? It uses Git's commit history, and we still have in here our work. And now if I do git push, it's no problem, right? Because we haven't changed previous commits. If I look here, I have the revert commit where I deleted this. And then I reverted my revert where I brought it back. So that can be really useful as well. And I think this is a good pausing point, and I just want to pause and check in and see what questions people have.
So instead of deleting, you can use this revert to effectively delete it, but keep the whole tree intact. Does that make
Correct.
sense? Is that right?
Yeah. Yeah. And the advantage is, for a print statement, just manually deleting this, like the way as I'm writing code, that's not a problem.
Yeah, but if you're like multiple files with lots of different lines that aren't
Right.
continuous and it's complex, that would
Right.
be the right way to do it.
Right. That's exactly it. Like, and in fact, now that I've screwed this up, let me use git to, if I do git status, let's do git restore. So restore will, I have some changes in my working tree that I haven't staged, right? I haven't done git add. So I'm gonna get rid of those and go back. So Nick, exactly like you were saying, if if I've modified like 3 different functions in 2 different files, Git revert will automatically undo those changes and it avoids the risk of like manual programmer error. Again, like right now when you guys are working with Git, just getting in the habit of doing lots of small commits is good. As you get more comfortable with it, your small commits can be more self-contained, right? Because revert isn't very useful if I have like a giant commit across 50 different files. It's useful if I have small self-contained commits. Um, I think in that vein, the last thing I'll show is something called rebasing. And this is a little more advanced, and I don't recommend using this, but again, I just want to show how we can work with commit histories. So let's bring up our graph here and let's look at main. So let's say I've been doing work and committing code as I go, and I decide, you know what, all these commits, they really belong as one, so that I have one self-contained commit with all of this different work. Let's say these three revert commits I want to combine. Rebase lets me combine commits if I use this -I interactive flag. And I'm going to say, let's look at the last 4 commits. And now I have this really interesting commit message. And this is almost like its own baby programming language. There's a command here, pick. There's a shorthand for a commit hash. And then there's the commit message. And we can see here instructions from Git on what these different commands do. I can change a commit message this way. I could in fact edit a previous commit, which I'm not going to show in this case. That can get a little trickier. I am going to show squash. So the order here is the oldest is at the top and the most recent is at the bottom. So by changing pick to squash, it's going to combine this commit with this one. And now if I change this, it's going to combine both of these into this one. And now when I save this, and let me reopen the graph and just show main. And I don't know why we see some of the other things, but now I should see, oh, it looks like, right, I've rebased, but I have to finalize my rebase. So this is getting a bit more advanced. It's telling me squash and all these different things. You are currently rebasing. I want to run, I believe, git rebase continue. And now notice that this combines all of those commit messages. And I'm just going to get rid of all of these and say I did stuff with Baz and go ahead and save and quit. And yeah, it's going to make me do this a couple times for each of the commits that I'm doing here. There is a cleaner way to do this. But now if we open up this graph and we go to the main branch, and if I look at git log, we see that I squashed those 3 commits into one. This can, again, I don't recommend doing this right now because it can cause some pain points. As you get more comfortable with Git, like a common workflow is if I'm working on a feature, I'll make lots of little work in progress commits. And then when I'm done, I'll like squash those 5 or 6 commits together into one, and then I'll push that up. Right. And like if I'm collaborating on a team, that's often what I'll do when I'm working on my own branch, because that way I can commit whenever I need to. I can have my messy commit messages, but then I can have everything nice, clean, and organized for other people to review and adding to the code base. Now, when I do git push, I do run into a problem here because the commit history has changed on the main branch. And I see this updates were rejected because these things are behind. So I know that this new version here on my local repo is the source of truth I want. So I'm going to do a force push. This is dangerous because I am now deleting this commit history for main on the other branch. But in this case, I know what I'm doing. Um, the one thing I want to say about a force push is when you guys get to group projects, you'll sort of collaborate on the main branch, but you'll have like individual feature branches you're working on. You never ever want to force push on like a shared branch that other people are using, right? That's going to cause a whole lot of pain for a whole lot of people. If it's just me working on a branch, that's totally fine. But if it's a shared branch, then that's going to cause problems. And so now all of those reverts and all those other things are just combined into one commit here. So let me just pause and check in and see if folks have questions or stuff that you're curious about.
So just to make sure I understand, all the changes you made in those little commits are still there. They just got compressed into one commit.
Yeah, correct.
So instead of
Correct.
having a whole bunch of nodes that do A, B, and C, you have one node that does A, B, and C all in one. And it's
Correct.
cleaner.
Correct. Um, and in fact, if we were to do this again, um, it gets a little trickier modifying, but if we wanted to rebase again and for whatever reason combine like these last three commits, let's just do git rebase. I had so the four, and I would squash and squash, and let's squash this one as well. And now this part's a little annoying. There's a setting you can do to change this. It wants me to modify multiple commit messages. So let's just, in fact, keep these different commit messages that I had from before. And let's just know, maybe we'll add the date and we'll just say that this is an interactive rebase. And maybe I'll just put in the commit message a reminder and I'll add this changes to be modified so that the commit message has all of this information. And now we have this one commit that I squashed those three or four into. And if we look here, we can see it has a number of changes.
It's got all the changes that you
Exactly.
did. Okay, in one. And now if you try to push it, it's going to complain because the commit tree doesn't match. And that's where the force comes in, right?
Exactly.
Because you're sure that's
Exactly.
what you want.
Exactly. I push, we get this complaint because exactly like you said, the commit tree for my local Git repo on the main branch no longer matches the commit tree for the Git repo for the main branch on GitHub. And Git does a very good job of being dumb. It doesn't try to be too smart and figure stuff out for us. It says, I don't know how to do this. I need you, the human, to tell me what to do. And in this case, because I know that the version I want, the new source of truth is my local repo with all the stuff I just rebased, I do a force push, exactly like you were saying. And now let me refresh this so we can see that. And now that's been overridden, right? And we see this nice big long commit message. I should have made the first line better, but I forgot. And we can see that this combines like those last 4 or 5 commits. So again, this is why I would not encourage you guys to use the interactive rebase. Um, or if you do, uh, before doing interactive rebase, just make a backup branch. And now, oh, there's already one that exists, but you know, backup before rebase. Right. And now if I'm on the main branch, if I really screw something up, I have on this backup before rebase branch the commit tree before I rebased it. But I really don't recommend doing the interactive rebase right now, um, unless you feel really, really comfortable with Git, because as you can see, it's dangerous because rebase destroys the commit history, right? It actually modifies commits. And whenever you're modifying commits, you are making permanent changes that there's no way to undo. Um, but it's useful to get a sense of like how Git works and how commits work, and to sort of get a preview of workflows as you get more comfortable with this. So I think the last thing I want to show is cherry pick, and then we can take a break. Um, well, actually, let's show a couple things. So let's make a branch and let's make a new file and let's call it some file. So let's say that I've decided that, you know what, I did work on this other branch and I want to grab that work and put it on my main branch. There's a couple ways to do it, but one way is with what's called Git cherry pick. And what I can do is I can grab that commit hash because a commit hash is unique. And I'm here on the main branch and I can do Git cherry pick and grab the commit hash. And now if I type git status, I see I'm ahead by one commit. If I do git log, I see this commit create some file has been grabbed and added to my main branch. You're not going to have to do that very often, but it is neat to see, and it does emphasize how a commit is like its own little independent unit of code. If you needed to go back in time on a branch, like let's say, let me branch off of main and we'll call this time travel. And let me push this up to GitHub so we have it. And let's say that I decided for whatever reason on the time travel branch, I want to go back to the very first commit. I can grab the commit hash and I can do git checkout and I can give the commit hash. And now we get this really long message. You are in detached head state. You can look around, make experimental changes, commit them. You can discard commits without impacting any branches. If I want to create a new branch or retain commits I create, I can do it with the switch command. So if I type git status, we see this head detached method, right? Because in essence, if I go back to, let's go back to our diagram and let me just draw a big fat arrow here real quick. right? If this was head for this branch, by checkout, we've changed that ref to go back here. So we're in essence in detached state. So, man, I don't, the git switch command does the same thing as checkout dash B. It's just a newer command. So let's say that here I wanted to change something on the README. So I have this sort of weird Git history, like, we're now not on the main branch anymore. These guys are kind of off over to the side, right? We still have the ref for head for main branch over here, but we've kind of detached the head for our commit tree for where we currently are is now this detached commit head. And so now if I want to be able to keep these changes, I need to make a new branch. We'll just call it my new branch. And I misspelled my new branch. But so now, what I've done is, sorry. And let's make this green. And we'll make this green. And, this is now the head for my new branch. And to go back, if we look inside that Git directory, and we look at refs heads, we see there's a file storing a head for each branch. And so if I go back to main, we still have all that stuff, but I have on the other branch where I like have moved back and done other work. So that's one way where you can kind of like move back to a previous commit if you realize you need to go back to a different version of your code. That workflow is less common. You're not going to do it nearly as much. And just to let us see that here on GitHub, let's go to this repo and let's look at the different branches that we've pushed up here. And we can see we have a number of these branches. We have the misnamed my new branch and its commit history here, where I traveled back in time on main to create README and added something and pushed it up. But main is unchanged. Right. And if I look at all the different branches on my repo, we can see here, here's main in purple. Here's my new branch where I had gone back in time. Here's my new branch where I'd gone back in time and added another commit that doesn't exist on main. Over here on foo and on the backup branch, we had those old commits that we actually rebased earlier, but those commits are still there on those other branches. the time travel branch was basically a backup of main and is literally the same thing. And in fact, we see here these two heads, main and time travel, and they point to the same commit. Right? So all a branch is really is a head that points to a most recent commit, and each commit points back to its parent commit or the previous link in the chain. So we've been doing all this manipulation, but then here on the graph, we can see that we have all of that commit history because we had it on a different branch, even though it's been rebased over here. And you can see how, now we really have a tree, right? That shows all of our branches and stuff. So let me just pause here and see what questions folks have, and then we can take a break because we have the retro coming up at 11. So I know I covered a lot of ground, especially towards the end of this. So I just want to check in to see if folks feel like you have a better understanding of how Git works and commit works. Okay, awesome. And again, over here in let me pull up the curriculum repo for this workshop. So there's a couple things in here, like part 2 is in here. There's some notes. Like if you look through these other files, you'll see some notes and some outlines of stuff. But these sort of core scenarios of I added some code that I want to unadd. I committed some code that I didn't push that I want to uncommit. The committed and pushed, I don't explicitly write out because that's a little more dangerous. But over here, there's a walkthrough of these commands and showing how to kind of use them in scenarios, and it builds out code a bit more. So I think you can use this as a reference for if you run into a scenario with Git and you feel like you need to undo something. And there's also, I do want to point out, where did I hide the link to it? There's a couple good links down here. There's some descriptions of the 3 trees of Git ignore, of Git from the bottom up. We actually also have floating around in our main curriculum repo. And I think it's under, yeah, here we go. I'll drop this link, but this is sort of a Git cheat sheet. So this can be useful to have as you're doing stuff. So I'll drop this link for you guys as well. All right, guys, thank you very much. Let me go ahead and pause the recording and let's take a break.